Shri Gurubhyo Namaha children. Welcome to our online teaching academy Ekalaiva. Today we are going to continue with 10th science. The topic today we are going to cover is domestic electric circuits. And in this we are going to see how electric circuit is connected or it is distributed to all the domestic and industrial consumers. So the electricity that is produced in power stations is distributed to all the domestic and industrial consumers through cables. Okay, overhead cables or underground cables are used to distribute it to our houses. Now this is the diagram which gives the domestic electric circuit. Now in our homes, electricity is distributed through domestic electric circuits. Now these circuits are wired by electricians. Now electricians will come to our house to do this connections. Okay, so what is the first stage is, now we should bring the power supply to the main box, okay, from a distribution panel. Now the distribution panel may be a transformer. Now you would have seen transformers along the roadside. So power from the transformers is taken, and there are two main components in the main box. Now it is connected to the main box. There are two main components in a main box, which is nothing but the first one is fuse box and the second one is meter. Now look at the diagram. Now here this is the main fuse. Now this is the main fuse and this is the electricity meter. Now here the number of units consumed by us is recorded here in this electricity meter, and here is the main fuse that is connected. Okay, now this is used, this electricity meter is used to record. Okay, so why do we use this electricity meter is to record the electrical energy, to record the electrical energy consumed. We use this electricity meter. Okay ma, right. Next, the fuse box. Okay, the fuse box here, it contains a fuse wire, or nowadays we go for what is called as MCB. MCB is nothing but a miniature circuit breaker. Okay, so what is the function of this fuse wire or an MCB? Now this is used to protect the household electrical appliances. Okay, now we are going to discuss about two concepts. One is overloading and the other one is short circuiting. So in order to protect the house from household electrical appliances, we go for a fuse wire or an MCB. Okay, now here an MCB. Now fuse wire we have already dealt with. Now an MCB, okay, now this is nothing but a switching device. This is an MCB which is shown in the diagram. Now this is a switching device. Now this can be activated automatically as well as manually. Okay, now this has a spring attached to the ends to this, which is connected to the switch, and whenever there is a very high flow of current in a circuit, now the circuit is broken, and we'll say that it is tripping. Okay, so the circuit will be breaking and the electrical appliances are saved. So this is the function of an MCB. Whenever there is a very high current flowing in the circuit, the MCB will automatically trip off, or the circuit gets disconnected, so that the electrical appliances are protected from heavy damage. So this is the use of an MCB, or you have a fuse wire. Okay, right. Now the electricity is brought to our houses by two wires. Now these are the two wires, children. One is a live wire, the other one is a neutral wire. Okay, now this live wire has a red insulation and this neutral wire has a black insulation. Okay, so the electricity supplied to our houses, okay, now it is an alternating current, it is an AC whose potential is electric potential. We have come across this word electric potential. So the potential that is supplied to our houses is 220 volt. Okay, and the frequency of AC is 50 hertz. This also I have already discussed. So in India, domestic circuits, they are supplied with an alternating voltage of 220 to, it varies, 220 to 30, it varies, right, and a frequency of 50 hertz, right. Now this live wire and the neutral wire, they enter into a box where the main fuse is connected with the live wire. Look at this. Now the main fuse is connected with the live wire. Okay, then it is passed on to the electricity meter, and after they pass through the electricity meter, these wires enters into the main switch. Okay, now this main switch is used to you can discontinue the electric supply whenever required. Suppose if I wanted to have any maintenance work in one particular part, this main switch is switched off so that the circuit is broken, right. And after this main switch, these wires are connected to two separate circuits. So what are these two separate circuits? Now in this, one circuit is connected to a 5 ampere rating. Now 5 ampere rating is, this is used to run electrical appliances like which has a low power rating. For example, tube lights, then electric bulbs, fans, they run with a 5 ampere rating power. Okay, so low power rating appliances are connected to this 5 ampere rating circuits. Okay, now the other circuit is a 15 ampere rating circuit which is connected to a high power rating appliances. For example, air conditioners. We use ACs in our house, air conditioners, then refrigerators, then whenever you use electric iron box, electric heaters. So all these are connected to 15 ampere rating. Okay, so that all the circuits, and here, so these are the two, this is 1 and this is 2. Okay, so according to the power rating of the electrical appliances, we go for a 5 ampere rating circuit or a 15 ampere rating circuit, right. Now the other thing, very important thing about this domestic electric circuit is, all the circuits in a house are connected in parallel. So parallel circuits are made. Okay, this also I have discussed when I was discussing about resistors connected in parallel. All the electrical circuits are connected in parallel. Now what is the advantage of connecting parallel circuits? Now if there is a disconnection of any one circuit also, that will not affect the other circuit. So all the connections are made parallel. Okay, and one more advantage of connecting parallel is the electric appliances. Now whatever electric appliances we were discussing about, now all the electrical appliances, they get an equal voltage when it is connected in parallel. Okay ma, so this is about domestic electric circuit, and we need to discuss two more things as far as these electric circuits are concerned. Now two things must be avoided. The first one is overloading, and the second one is what is called as earthing. Okay, not earthing, sorry children, it is short circuiting. So what is this short circuiting also I'm going to discuss. Two things I'm going to discuss. Now this has to be avoided. Okay, so what is overloading? That is what we are going to discuss now. So overloading, now this is the diagram, overloading. So you can very well understand from this diagram. Okay, now the current that is flowing in a wiring circuit, now at a particular time, now all the current flow depends on mainly the power rating of the appliances. Okay, power rating. So current flow depends on power rating of the appliances that is used. Okay, so this is a very important point, right? Now, suppose let us consider we connect too many appliances of very high power rating. For example, at the same time you switch on an electric iron box, you switch on your electric geyser, you switch on your AC, all these things are switched on at the same time. What will happen, children? Now, due to an extreme, now definitely when all the appliances are switched on at the same time, now the current flow, now all these electrical appliances, they draw an extremely large current. Yes or no? From the circuit. So, this is nothing but you call it as overloading. Now, so let us consider, now here I connect so many appliances. Now, this will take a very high amount of current. So, what happens when there is an extremely large flow of current flowing in a circuit? Now, the wires, they get heated up and there may be a fire accident due to this. So, this should be avoided. Overloading should be, you should not connect electrical appliances which is of very high power rating at the same time. So, that should be avoided, right? So, overloading should not happen, because when overloading happens, current flow will be there in the circuit which leads to a fire accident, which heats the wiring. Okay, the wiring gets heated up, which causes a fire accident. So this should be avoided. Okay, and the next is short circuiting. So what is this short circuiting? So whenever we do plastic insulation of the live wire and the neutral wire, so when they touch each other, okay, when the plastic insulation of this live wire and the neutral wire, when they touch each other, now this is nothing but you call it as short circuiting. Okay, short circuiting is nothing but touching of the live and the neutral wire directly. Okay, there will be insulation, but if the insulation is torn, now this live wire and neutral wire, they touch. Okay, so this is nothing but you call it as short circuit. Okay, so what happens when they touch each other? Now when they touch each other, the resistance of the circuit, okay, so what happens, the resistance is, since the resistance is becoming very very small, now immediately there will be a current raise. Okay, there will be a very high current that will be flowing in the circuit, and definitely again what happens, heats the wires. Okay, and again here also there is a chances for a fire accident. So these two things must be definitely avoided. So that is why we connect this electrical fuses. So when this is happening, now this electric fuse, what does it do? The wire is protected. Okay, these wires or the heating process is protected by the fuse wires or the MCBs that are connected in the circuit. Okay, and one more thing that is done for the safety of electrical appliances is earthing. So what is this earthing? You would have seen this earthing in your houses. Now near the meter board, there is a big meter board, right? Now you can see that the meter board will be connected to the earth by a metal wire, which is called as earth wire. So earthing is nothing but earthing. This has to be done. Definitely it has to be done, because whenever we give electric circuits, the first thing you should do is earthing. Okay, so what is earthing? Earthing means to connect the metal case of electrical appliances. To connect the metal case. Okay, metal case of electrical appliances electrical appliances to the earth. To the earth. Now, earth is said to possess zero potential. So, all the electrical appliances, it has to be connected. It has to be connected to the earth. Okay. So, when you see this household circuits, we have three wires now. One is the live wire. The second one is the neutral wire. And the third one is the earth wire. Okay. So, one end of the earth wire is definitely buried deep into the earth. Okay. So, when we connect the earth wire to the metal case of the electrical appliances by a 3-pin plug. Okay. So that all the appliances are protected from shock. Suppose if you have a very high flow of current, once again, now since the electrical appliances, the metallic body of the electrical appliances, when you go and touch, if there is a very high flow of current, immediately you may get a shock. So to avoid this, suppose if there is a small child in your house going and touching the metal body of an electrical appliances with a very high current, immediately the child will receive a very high electric shock. So to avoid this, this has to be done. Earthing has to be done. Okay, definitely earthing is done to protect the metallic body of an electric appliance from very high shock. So all these things has to be made whenever a domestic electric circuit is done. So this is about domestic electric circuits. Now with this we are moving on to some of the numericals of the book back questions. Now this is the first numeral. An electric iron. Okay, here we talk about an iron box. Electric iron consumes energy at the rate of 420 watt when heating is at the maximum rate and 180 watt when heating is at the minimum rate. The applied voltage is 220 volt. What is the current in each case? So we know the formula for power. I am going to use the formula for power. Power is voltage into current. So P is V into I. So I need to determine what? Current in each case. Now there are two conditions they have given. So one is when heating is done at the maximum rate. So when heating is done at the maximum rate, what is the power consumed? The power consumed is, the heating rate is 420 watt. So first, when heating is done at maximum rate, when heating is at the maximum rate, what is the current? So I need to rearrange this formula. So I now becomes I is equal to P by V. I have the values. Okay, so current will be I. What is the maximum rate power? They have given 420 watt. So it is 420 divided by the voltage is 220. So 0 gets cancelled. So you divide this 21 by 11. Okay, so when I simplify, I have the value of current to be, this will be 1.909 ampere. So this is the current when heating is done at the maximum rate, right? Now next we are going on to when heating is done, when heating is at the minimum rate. So when heating is at the minimum rate, what is the value? I is equal to 180 they have given. So it is 180 divided by 220. Again 0 gets cancelled. So this is 9 by 11. 2 9s are 18, 2 11s are 22, and you have the answer to be 0.818 ampere, where the value of current is 0.818 ampere. So this is the value of current when heating is at the maximum rate. Now this is the value of current when heating is done at the minimum rate. Okay ma? Right. Next sum. A 100 watt electric bulb is used for 5 hours daily and 4 60 watt bulb are used for 5 hours daily. Calculate the energy consumed in the month of January. So we know that electrical energy formula, electrical energy, commercial unit of electrical energy is, we have already discussed, which is power into time. So let us write the formula first. Electrical energy formula is power into time. So we need to express the answer in kilowatt hour, right? So let us start with the electric bulb. So what is the energy consumed by 100-watt bulb? Okay, so 100-watt bulb, again formula is power into time. So the power of the electric bulb is 100-watt into, now the time is, they said that it is used for the month of January and it is used for 5 hours daily. So in one day, if we use it for 5 hours, we need to calculate it for 31 days. So it will be 31 into 5. Okay, ma? So when I simplify this, the answer will be 15,500. But we need to express this in kilowatt hour. So when I express this in kilowatt hour, this will be 15.5 kilowatt hour. So this is the energy consumed by a 100-watt bulb for the month of January, right? If it is used for 5 hours per day, right? Next we move on to the electric bulb. Okay, so this bulb, okay, right? Now here, how many bulbs are used? 4 electric bulbs are used and it is used for 5 hours daily. You need to calculate it for the month of January. So again, energy consumed by 460-watt bulb. Okay, 460-watt bulbs. So what should be? So 4 into 60 into, then again it is used for the month of January. It is used for 5 hours per day. Now here we calculated for one electric bulb whose power rating is 100 watt. Now here we are calculating for 460-watt bulb. Okay, so try to understand the sum clearly. So it is 4 into 60, right? So when I simplify, I will have 37,200 watt hour. Okay, now when expressed in kilowatt hour, it will be 37.2 kilowatt hour. Now I need to find out the total energy. I need to add both the values. So total energy consumed. So total energy consumed will be 15.5 plus 37.2, which is 52.7 kilowatt hour. So this is the total energy consumed for the month of January by the electric bulb of different power ratings. One is 100 watt, the other one is 60 watt. Clear? Right? Okay. So next sum. A torch bulb is rated at 3 volt and 600 milliampere. Calculate its power. So this is a very easy sum. Direct substitution. Power is, what is the formula for power? Power is V into I. Okay, ma? So V is given. What is V? We know the value of V. 3. 3 into current is given as 600 milliampere, children. Milliampere current is 600 milliampere, which can be written as 600 can be written as 6 into 10 power 2. Milli is 10 power minus 3. So this will be 6 into 10 power minus 1 ampere, the current. Okay. So this has to be substituted here. So 6 into 10 power minus 1. So when I simplify, I have the answer of power to be 1.8 watt. Okay. Then the second one is resistance. What is the formula for resistance? Resistance is equal to V by I. Again substitute for V as 3, I as 6 into 10 power minus 1. So when I simplify this, again I'll have the answer. Here 3 by 6 is 1 by 2. 1 by 2 is 0.5. When I take this 10 power minus 1 to the numerator, it becomes 5 ohm. So the resistance is 5 ohm here. Okay, direct substitution of the formula. Next is energy consumed. So energy formula is power into time. Okay, so power we have already found out. Okay, so power is 1.8, time they have given it is for 4 hours, so it is 4. So the answer is 7.2. Now the answer I am going to give as watt hour. So energy is 7.2 watt hour. Okay, so this is the answer. So we have found out the answer, direct substitution of the formula. It's a very easy sum, right? Next we are moving on to the fourth one, very important. Look at this. A piece of wire having a resistance R is cut into 5 equal parts. Now let us take a wire. Okay. Now this is having a resistance R. The resistance of this wire is R, children. Now I have cut this into 5 parts. Okay. So when I cut it into 5 parts, the first question is, how will the resistance of each part of the wire change compared with the original resistance? Okay, so what will be the resistance of each part now? The total resistance is R. If it is going to be divided into 5 parts, each part will be what? Each part will be having the resistance of R by 5. So which is the first answer. So therefore, for A, what is the resistance of each part? So the resistance of each part is R by 5. Okay, ma? Clear? The next question. If the 5 parts of the wire are placed in parallel, how will the resistance of the combination change? We know the formula for resistance in parallel. What is the formula, children? It is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. Okay. So let us substitute each value. So 1 by Rp. Now what is the value of each value of resistance? It is R by 5, right? So each part has a resistance of R by 5. So 1 by R1, I am going to substitute 1 by R by 5 plus 1 by R by 5 plus 1 by R by 5. Again 1 by R by 5 plus 1 by R by 5. So this 5 goes to the numerator. So this becomes 5 by R plus 5 by R plus 5 by R plus 5 by R and one more 5 by R. So what is 1 by Rp here? 1 by Rp will be 25 by R. Okay, which implies Rp will be R by 25. Right? So when resistors connected in parallel, the effective resistance will be Rp equal to R by 25. Next, what is the C option? What is the C question? What will be the ratio of the effective resistance in series connection to that of the parallel connection? So they are asking us to find out Rs by Rp. Okay? We know the value of Rp, children, but we don't know the value of Rs. So first let us find out Rs. So Rs is resistors connected in series. Yet net effective resistance will be R1 plus R2 plus R3 plus R4 plus R5. So what is the value of each resistance? It is R by 5. So combination of R by 5 plus R by 5 plus R by 5. So when I do this, what will be the effective resistance? Now this will be 5R by 5, right? 5 gets cancelled. So which implies Rs is equal to R. Am I right? Now I am going to find out the ratio. So Rs by Rp. Now this will be Rs is R. Rp will be R by 25. So this 25 will go to the numerator. So R gets cancelled. So the ratio of Rs is to Rp is 25 is to 1. Okay, so these are all very, very important numerical problems and it is also very easy to solve. So please work out these problems. We'll be continuing with the next lesson in the next video, children. See you then. Bye.